Bismillah, we continue in the series of lecture concerning the course Applied Pharmacognosy for the fifth year's pharmacy student. In this year lecture, we will talk about qualitative chemical determination of extract constituent of medicinal plants. Qualitative chemical determination means the use of chemical reaction to detect the presence of important classes of secondary metabolite in plant extracts. These secondary metabolites include alkaloids, flavonoids, tannins, saponins, and so on. As we know, these secondary metabolites are responsible for the therapeutic action of this medicinal plant. The content of this lecture involves two parts. In the first part, we will talk about the type of chemical or the type of qualitative determination of extracts, mainly divided into two classes: physical techniques and chemical techniques. The physical techniques we discussed in details in the third year when we talk about the course of chromatography. And the second class of techniques used for determination of extract constituent is the use of chemical test. In this lecture, we talk in details about the chemical test used in identification of these secondary metabolites. What do we mean by plant constituent? Or in other words, what are the plant constituent? Plant constituents are secondary metabolites or phytochemicals that are responsible or determine the therapeutic value of a medicinal plant. As we know, phytoconstituent or phytoconstituent are working individually or in combination or as synergistic action to provide the therapeutic value of the medicine plant. The important group of secondary metabolites or phytoconstituents that having diverse biological activities include alkaloids, flavonoids, phenolics, tannins, saponins, and etc. Now the very important question is that what is the importance of identification of plant phytoconstituent, or why we identify the plant secondary metabolites? The answer is that because these secondary metabolites are responsible of the pharmaceutical activity of the plant. So the plant pharmaceutical activity can be predicted by the presence of these secondary metabolites or phytoconstituents. You have two types of techniques used for qualitative determination of phytochemicals, mainly physical techniques and conventional chemical tests or conventional chemical techniques. The physical techniques include the chromatographic techniques, that which we studied in the third year, including gas chromatography, liquid chromatography, HPLC, HPTLC, and so on. And the other class, chemical constituent, and it is including chemical tests for identification of important class of secondary metabolites. For example, alkaloid can be detected by Hagas reagents. Carbohydrates can be detected by Molish test or Molish reagents. Carbon glycoside can be tested by Kidis test or Kidis reagents. In this lecture, we will talk in details about these conventional chemical tests because These chemical tests are economics and easy to be applied and require few resources. So they remain as a good choice for qualitative determination of secondary metabolite. The qualitative chemical test for other chemicals in this presentation we will describe the qualitative chemical test for 17 important classes of secondary metabolites. The first class of secondary metabolites can be described in this presentation is alkaloids. There are 8 chemical tests used for detect the presence of alkaloid in secondary in plant extract. One of them is dragon doors or Kraut's test, where dragon doors give reddish brown precipitate with presence of alkaloids. Haggard's test and Haggard give greenish white precipitate, which indicates the presence of alkaloids. Myers test, or known as Bertrand test or Valser test. Myers give greenish, white, or yellowish precipitate. Wagner test give brown to reddish precipitate. Picric acid test, which use 2% picric acid solution, and these reagents give an orange color for presence of alkaloids. Iodine test give blue color, which disappears on boiling and reappears on cooling. Boschardat test, Boschardat reagents consist of ethanol with addition few drops of dilute iodine solution. This test gives reddish to brown color. And the last test, tannic acid test, which consists of 10% tannic acid solution. This test gives a buff color precipitate. As appeared in this slide, the first force reagents give precipitate or change in color, including dragon doors, Haggard's, Myers, and Wagner's. All of them give precipitate in addition to color change. Besides the last one, tannic acid test also give precipitate in addition to change in color, while the other mainly give change in color, including picric acid, which give an orange color, iodine test give blue color, and Boschardat test give reddish brown color. Carbohydrates classified as primary metabolites, but they have important physiological role for living cells. It's considered as source of energy because they can be converted into glucose. Glucose enters metabolic cycles to produce energy or convert it to other important metabolites. Besides its function as a source of energy, carbohydrate can be a part of glycosides, which can be used for solubilization or transport of these glycoside, and mainly transfer of a glycone as the active part of or physical active part of glycosides. Here we have 4 types of qualitative chemical tests used for detection of carbohydrates in plant extracts. One of them is Barfoed test. Brontrager test consists of copper sulfate, glacial acetic acid with heating. The presence of carbohydrates with Brontrager test give red precipitate. Well, this test mainly used for monosaccharides like glucose, fructose, and so on. Molasses test also used for detection of carbohydrate, and molasses consist of alcoholic alkaline salt plus sulfuric acid, concentrated sulfuric acid. Molasses test give violet ring, detect the presence of carbohydrate in plant extracts. Sylvanov's test, are known as resorcinol test, consists of resorcinol plus dilute HCl and heating for 1 minute. For ketosis, resorcinol test gives rose red color. The last test for carbohydrate is test for pentosis, which consists of concentrated HCl, beside fluorouracil, and heating over flame. If carbohydrate, mainly the pentosis, present in extract, the color of extract changes to red color. Reducing sugars are the type of sugars, maybe monosaccharide or disaccharides, which having free aldehyde أو ketone functional group. مثال reducing sugar, glucose, mannose, and fructose. They باعتبار monosaccharides. Also there is some disaccharide also can be classified as reducing sugars, and its example is maltose. Reducing sugar, its importance in phytochemistry, they are considered as part of glycosides. There is two qualitative chemical tests for detecting the presence of reducing sugars, including Bendix test and Fehling test. A Bendix test gives green, yellow to red color with reducing sugars. Bendix test itself consists of bending reagents, consists of two solutions. Solution A composed of sodium citrate and sodium carbonate, and solution B consists of copper sulfate. And when the solution composed of these two solutions, sodium citrate, sodium carbonate, beside the copper sulfate. The another test is Fehling test, which Fehling A consists of two solutions. Solution A copper sulfate, and solution B consists of potassium sodium citrate beside sodium hydroxide. Fehling test give red precipitate with reducing sugars. For glyphosate, there are 6 types of qualitative chemical tests used for detecting the presence of glyphosate in plant extract. As we know, glyphosate consists of two parts, A-glycone and sugars. The A-glycone may be any class or any compound of secondary metabolites, maybe steroids, maybe flavonoids, alkaloids, and so on. And the other part is sugar, maybe monosaccharides, one or two monosaccharides, maybe reducing sugar or non-reducing sugar. Glycosides have different types, the O glycoside, C glycoside, N glycoside, depending on the glyceric bond that link between A-glycone and sugars. For qualitative chemical test, we have the first test is Brontrager test. Brontrager used for detecting the presence of anthraquinone glycosides, and Brontrager test consists of chloroform, or chloroform extract beside 10% ammonia solution. Brontrager test give pink colored solution in case of presence of unsaturated glycosides, mainly O glycosides. Modified Brontrager test consists of perchloride solution beside ammonia solution, which involve extraction with benzene and boiling for 5 minutes. Modified Brontrager test give rose pink to blood red colored solution for presence of anthraquinone glycosides, or in this case mainly C glycosides. So the main difference between Brontrager test and modified Brontrager test is the test, a class of secondary metabolite can be tested. Both of them used for detection of unsaturated glycosides, while Brontrager for all glycosides and the modified Brontrager used for C glycosides. The difference بيعتمد على الجلايكوسيديك bonds. In case of the composition of the reagent, Brontrager consists of ammonia solution 10%, while modified Brontrager consists of ferric chloride beside ammonia solution and heat. The third chemical test for detection of glycoside is Legal tests. Legal reagents consist of 10% sodium hydroxide solution besides sodium nitroprusside can be added to plant extract extracted with pyridine solution. The legal test give pink color solution in case of presence of cardiac glycosides, and it is mainly the test for detecting the presence of unsaturated bond in lactone ring or in the lactone fraction of cardiac glycosides. The aqueous sodium hydroxide solution, also considered as a general test for glycosides, consists of aqueous sodium hydroxide solution can be added to alcoholic extract of plant alcoholic plant extract. Aqueous potassium hydroxide solution give yellow color with glycosides. The concentrated sulfuric acid test, the reagent consists of 5% ferric chloride in addition to sulfuric acid and glacial acetic acids. Also, this test gives brown ring, indicates the presence of glycosides. And the last test is Raymond test. And Raymond reagent consists of dinitro benzene in hot methanolic alkalis. The Raymond test gives violet color. والتest Raymond used for detect the presence of steroid nucleus in cardiac glycosides. Generally, for glycosides, tests for glycosides, we have two tests for anthraquinone glycosides, including Brontrager test and modified Brontrager test. And we have two general tests for cardiac glycosides, including legal test and Raymond test. The specific test for detection of cardiac glycosides, we have four qualitative chemical tests, starting with killer clear test, and the second one is kidney test, the third one bromine water test, and the last fourth test is Baljet test. Killer clear test its reagent consists of glacial acetic acid besides 5% ferric chloride and Kong sulfuric acid, concentrated sulfuric acid. Killer clear test give blue colored solution in acetic acid layer, indicates the presence of cardiac glycosides. While kidney test consists of few milli of methanol and few milli of alcoholic potassium hydroxide, beside few drop of alcoholic 3,5-dinitropentene. Besides heating all this range added to extract, and if the color disappears or having disappearing violet color, this indicates the presence of cardenolites. We have two types of cardiac glycoside, bufadienolides and cardenolides, and this classification based on the presence of the lactone ring, if it is butyrolactone ring or furanolactone ring. Key reagents give violet color, disappearing violet color with cardenolides. Bromine water test give yellow precipitate with cardiac glycosides, and Balch's test as reagent consists of 1% picric acid and 10% potassium hydroxide solution. Balch's test give yellow to orange color in case of presence of cardiac glycosides. Proteins and amino acids have various functions in the living cells. Proteins and amino acids are a part of enzymes used for production of enzymes and also have a function in immune system. On the other hand, amino acids are precursors or building block for biosynthesis of other important secondary metabolites and mainly for biosynthesis of alkaloids. We have three types of qualitative chemical tests used for detection of presence of these proteins and amino acids in blood crystals. One of them is Biorate test, and the second one is Melon's test, and the third one is ninhydrin, which is specific for detecting the presence of amino acids in blood crystals. Biorate test consists of Biorate reagents, which consist of 2% copper sulfate, beside 1 milli of 95% ethanol and potassium hydroxide base. Biorate reagents give a pink color solution in ethanolic layer of plant extracts if they contain protein and amino acids. Melos reagents consist of 1 gram mercury إضافة nitric acid, human nitric acid, and equal amount of distilled water. Melos reagents give white precipitate for presence of amino acid and proteins. Ninhydrin test give purple color solution in case of presence of amino acids. And ninhydrin reagents consist of 2 drops of ninhydrin solution, which is consists with 10 milligram ninhydrin and dissolved in 200 ml of acid. Flavonoids are considered one of the important class of secondary metabolites present in plant extracts. Example for flavonoid is naringine and quercetin, which are present on the peel of citrus fruits such as orange and grapefruits. Flavonoids have various pharmacological functions. There is 8 qualitative chemical tests used for detection of presence of flavonoid in plant extract. One of all is alkaline reagents, which itself consists of 2 reagents, 2% potassium hydroxide solution below HCl, and the second one 10% ammonium hydroxide solution. With the first alkaline reagent, sodium hydroxide, beside HCl. The presence of flavonoid gives intense yellow color, which become colorless on addition of dilute acids. While with 10% ammonium hydroxide solution, the presence of flavonoid can be detected by the change of the color of extract to yellow fluorescence. The second test is use of lead acetate test, which consists of 10% lead acetate as reagent. It gives also yellow fluorescence in case of presence of flavonoid in plant extract. Shinoda reagent consists of magnesium ribbon fragment dissolved in conch HCl. Shinoda test gives pink to crimson color solution in case of presence of flavonal glycosides. That means Shinoda test is test for flavonoid glycosides, not for free flavonoids or free aglycols. The fourth test is Shibata reactions or cyanidine test. Shibata reagents consist of metal magnesium or magnesium metal dissolved in 50% methanol solution with heating and beside addition of few drops of conch HCl. Shibata reagents give red color with flavonols and orange color with flavonols. Orange colors with flavones and red color with flavonols. Flavonols are alcohols and flavones are ketone as predicted from their name. Ferric chloride test. The reagent consists of 10% ferric chloride solution, and this test gives a green precipitate with flavonoids. Buse test consists of metallic zinc in conch sulfuric acids, give red color for flavonols, also similar to Shibata reagents, while Shibata gives red color with flavonols, also Buse test give red color with flavonols. The difference in the reagent for the two tests. Zinc chloride solution test. Its reagent consists of pinch of zinc oxide or zinc dust, and conch HCl can be added gradually on the side of the test tube because it is explosive or reduce flame on addition of sulfuric acid. Zinc chloride solution. Zinc chloride reduction test gives reddish to purple color in case of presence of flavonoids. And the last test for flavonoids is sulfuric acid test, which use conch sulfuric acid test, and it gives an orange color in case of presence of flavonoid in the plant extract. The phenolic compounds include secondary metabolites having the nucleus of phenol, such as tannins. There is 7 qualitative chemical tests used for detection of phenolic compound. First of all, iodine test, which consists of few drops of dilute iodine solution. When added to plant extract, a transient red color produced in case of presence of phenolic compound. Ferric chloride test consists of 5% ferric chloride solution. Ferric chloride test gives dark green to bluish black color when the presence of phenolic compound is confirmed. Gelatin test consists of 1% gelatin solution and 10% sodium chloride. They form white precipitate. Also, the lead acetate test, which consists of 10% lead acetate solution also divide precipitate with the presence of phenolic compound. The lactic acid test consists of 5% glacial acetic acid beside 5% sodium nitrate solution. This test gives muddy solution or solution turned to muddy and dark brown precipitate. Means muddy means viscous or turbid solution with dark brown precipitate. The sixth qualitative test for phenolic compound is potassium dichromate test, which consists of few drops of potassium dichromate solution. It gives dark color. And the last test is hot water test. Hot water test consists of warming the mature plant part, warming of mature plant part in water. The change produced is black to brown color ring at the junction of dipping. This indicates the presence of phenolic compound. Saponin is another important class of secondary metabolites. They characterize in their chemical nature. They have steroidal nucleus, and most of them are glycosides. So you can call saponins as triterpenoidal glycosides. Example of saponin, sabugenin and rhiadogenin that present in fenugreek seeds أو في بذور الحلبة. تتميز السابونيز بأنها تكون من steroidal nucleus. Here we have four qualitative chemical tests used for detection of saponins in plant extracts. One of the important characters for saponins, they are forming foam of the amber رغوة on agitation with water. Another important biological functions or biological characters بالنسبة للسابونins, they can produce hemolysis of blood cells. So it can be detected by hemolysis test by using RBCs or blood cells. One of the tests used for detection of saponins is foam test. And the second one is sodium bicarbonate test. And the third one is olive oil test. And the last one is hemolysis test. The fairest of all, foam test, can be divided into 3 subclasses depending on the amount of the plant extract used and amount of water used. The fairest foam test subclass اللي هو use of plant extract with 2 ml of water and shaking, vigorous shaking. In case of presence of saponins, foam is formed for and persists for 10 minutes. The second test of foam test is use of 20 ml of water besides 50 grams of plant extract with vigorous shaking for 15 minutes. In this test, the foam formed having 2 cm thickness. The third foam test consists of 0.2 gram plant extract besides 5 ml distilled water, also with shaking, and besides shaking, heated to boiling. In case of presence of saponins with this foam test, the appearance of creamy mess of small bubbles. Presence of small creamy mess bubbles in the third foam test. The second test of saponins is addition of sodium bicarbonate. Sodium bicarbonate solution can be dissolved in distilled water and vigorously shaking. So if the saponin present in extract, a stable honeycomb-like froth is formed. Stable honeycomb-like foam or froth is formed. With olive oil paste, which consists of 5 ml distilled water and few drops of olive oil with vigorous shaking. Also, we know the appearance of foam if the saponin is present. The last or the fourth test for saponin is hemolysis test. In this test consists of blood, few drops of fresh blood, placed on glass plate, and then the blood extract is added. If the saponin present in extract, we note or we show the presence of zone of hemolysis in case of presence of saponin. And this test is based on the biological activity or the activity that saponins are toxic and cause hemolysis of RBCs. The other three tests considered as physical test, foam test, sodium bicarbonate, and olive oil test. All these three based on the formation of froth or foam in case of presence of saponin. The plant phytosterol detected by three qualitative chemical tests. One of them is Salkowski test. Number two, Lieberman-Borchardt test. And number three, Hesse response test. Salkowski test consists of few drops of concentrated sulfuric acid shaken well and allowed to start. If the extract contains phytosterol, red color is produced in lower length. Lieberman-Borchardt reagent consists of acetic anhydride, plant extract dissolved in acetic anhydride solution, and then few drops of concentric acid added along the side of the test tube gradually to avoid the explosion. If the phytosterol present in extract, an array of color change is noted in the test tube, which indicates the presence of phytosterol in the plant extract. The third phytochemical or the third qualitative chemical test is Hesse response test, which consists of few milli of chloroform and few milli of sulfuric acid added to aqueous plant extract. So we note a pink ring or red color in lower chloroform layer is produced in case of presence of phytosterol in the plant extract. Terpenoids are a class of secondary metabolites biosynthesized through mevalonic acid or deoxylose phosphate. In the nucleus, there are consist of steroidal nucleus or consist of terpene as building block in their structures. Terpenoid can be classified in three classes based or depending or for the purpose of qualitative tests. Can be divided into cholesterol, triterpenoids, and diterpenes. Cholesterol consists of 30 carbon atoms, compound with 30 carbon atoms. Also, triterpenes consist of 30 carbon atoms, while diterpenes consist of 20 carbon atoms. For detection of cholesterol, we use acetic anhydride test, which consists of few drop of acetic anhydride and few drop of sulfuric acid. Cholesterol, if present in extract, the color change to a gray colored solution. White triterpenoids can be detected by Salkowski test, similar to phytosterol, which we speak about in the previous slides. Salkowski reagent consists of few drops of sulfuric acid, shaken well and allowed to stand. In case of presence of triterpenes in plant extract, a golden yellow layer at the bottom of the test tube is produced. While diterpenes can be detected by using qualitative test, which consists of 3 to 4 drops of qualitative solution added to plant extract dissolved in distilled water. In case of presence of diterpenes in the plant extract, emerald green color is produced. Emerald green color or green color of emerald تعني الزهور اللون الأخضر المايل للون الزهرود. Anthraquinone is another class of phenolic compound. We talk about anthraquinone glycosides when we speak about the test for glycoside, and we said we use Brontrager test and other type of tests for presence of glycosides. Here for anthraquinone, there is two types of tests, Brontrager test and ammonium hydroxide test. Brontrager's reagent consists of 10% ammonia solution and shaken with few ml of filtrate for 30 seconds. We add 10% ammonia solution to few drop of filtrate and shaken for 30 seconds. If anthraquinone present in the extract, a pink to violet or red color is produced. Another test is ammonium hydroxide solution test, which consists of few drop of ammonium hydroxide solution added to 10 mg of plant extract dissolved in isopropyl coconut. In case of presence of anthraquinone, formation of red color is observed after 2 minutes. Fixed oil and fats are classified as primary metabolites. They have physiological roles because they are a source of energy, can be converted into another intermediate useful for production of energy, and precursors for biosynthesis of other secondary metabolites and also primary metabolites. For fixed oil and fat, there is two tests, a spot test or stain test, which is considered as physical test, while another test is saponification test and it's classified as chemical reaction test. In a spot test or stain test, we can place a little quantity of plant extract and press it between two filter papers. We take few amount of plant extract and we can pressing نعمل pressure أو ضغط أو نعمل تحريك للفلتر بيبر على البلانت extract. We can note that after few minutes there can be oil stain on filter paper and resistant. This means it is fixed oil. While or if the oil stain disappears after few times, this means the oil may be volatile oil or essential oil. As we said previously, a spot test or stain test is a physical test. The second type of qualitative test used for detection of fixed oil and fat in plant extract is saponification test. And the test composed of addition of few drop of 0.5 normal alcoholic potassium hydroxide and few drops of phenolphthalein besides heating for 2 hours. This test based on formation of soap by addition of potassium hydroxide. If the fixed oil or fat present in the plant extract, the soap is formed or partial neutralization of alkali occur if it is free fatty acid. Resins are a class of secondary metabolites which consist chemically from essential oil or volatile oil beside gums or carbohydrates. There are two tests for detection of resins: acetic anhydride test, which is considered as chemical test, and turbidity test, which is considered as physical test. Acetic anhydride test consists of acetic anhydride beside 1 millicom sulfuric acid. In case of evidence of resins, orange to yellow color is produced, while for turbidity test have two subclasses. One of turbidity test by addition of 10 millி 4% HCl, and we know the turbidity of the solution produced due to presence of resins. And the second type of turbidity test is by dissolving the plant extract in acetone and transfer it to distilled water. Also, turbidity produced in solution indicates the presence of resins in plant. In this slide, we describe the qualitative chemical test for anthocyanins and coumarins. Anthocyanins and coumarins, both of them are secondary metabolites, while anthocyanins belong to the class of flavonoids and can be synthesized through chemical acid pathway. Also, coumarins are phenolic compound biosynthesized through the same pathway اللي هو chemical acid pathway. Anthocyanin can be detected by addition of HCl test. HCl consists of 2 normal HCl and few drop of ammonia. If the anthocyanin present in the plant extract, being created solution which turn to blue violet after addition of ammonia. This HCl test for anthocyanins. If it is present in the plant extract, red color is produced and the red color is changed to blue or violet color after addition of ammonia. For coumarins, the test consists of sodium hydroxide paper test, and this test consists of 0.5 gram moist extract is taken into test tube, and in the test tube mouse covered with 1 normal potassium hydroxide solution treated on filter paper. Then we apply heat for few minutes in water bath. If coumarin is present in the plant extract, we change yellow fluorescence from the paper and the UV light is produced. The last group of chemical constituents present in the plant extract is gums and mucilage. Gums and mucilage are detected by alcohol test as qualitative chemical test. With alcohol test, gums produce white or cloudy precipitate, and the content itself consists of absolute alcohol added to 10 milli of plant extract, which consists of 100 milligram of extract. In other words, we have plant extract 10 milli dissolved in distilled water, and the extract is formed by addition of 100 milligram of the plant material. For this extract, we add 25 milli absolute alcohol and with consistent stirring. The change produced is formation of cloudy precipitate or white precipitate, which indicate the presence of gums. Or by the end of this lecture, we know the qualitative chemical test used for determination of active plant extract obtained from medicinal plants. As we said, the qualitative test means the use of chemical reaction to detect the presence of important classes of secondary metabolites. And we said that the chemical test is used for qualitative analysis because it is feasible and can be used easily for detection for qualitative detection of secondary metabolites. In this presentation, we talk about the qualitative chemical test for 17 classes of important secondary